Hello, everyone. We are continuing with our exam review. So we'll continue with the exam review. All right. So we are given antiderivatives. We're given antiderivatives. So this is an indefinite integral, and we are told to find the indefinite integral. Remember that this is an exponential function. So whenever you have an exponential function, the first thing you want to do is rewrite. There's nothing to rewrite. So now you do 1 over natural log of the base of that, then multiplied by the number. What is the number? 12 to power x, 12 to power x. So multiply by the number. Remember, it's an indefinite integral, so it had to contain the constant c. All right, so when you finish, you can leave your answer like this, or you can rewrite 12 to power x over natural log of 12 plus the constant c. Therefore, your antiderivative, the original function, we can put capital here, is equal to f of x is equal to 12 to power x over natural log of the base plus c. Okay, so that is the antiderivative or integration of an exponential function, this ordinary exponential function. Okay, let's go to number 5. Remember that we are only doing some of them. You are not going, you have to study the rest. I'm just going to help with a little bit. Okay, so let's make sure we do the ones that people are confused about. When you are given an antiderivative, you want to rewrite it, you want to eyeball it, that's like number 6. Eyeball this antiderivative, the function. The function in there is, let me just put all of them in, is in the numerator x minus 4 all over x minus 2 dx. Well, if you look well, you will notice that the numerator is difference of 2 squares. So you want to rewrite, simplify using all the algebra you need to use so that you are integrating the simplified function. So this is the same as integral. The numerator can be written as x plus 2 multiplied by x minus 2, since it is a difference of 2 squares, all over x minus 2 dx. So this first expansion and gives you some points. It gives you some points to show that you know you have to simplify algebraically. Then there are things common, cancel what is common. Then you bring down the remainder. So you are now integrating the remainder, dx. So when you finish, you now integrate the remainder. We're integrating this function, we see that the original function f of x is going to be, it's an indefinite integral. So you have you have x to power 2, and then remember that you can use the power function. So you have x to power 2, this is 1, plus 2x plus 0. Okay, so and then you remember that you are going to also put that in the denominator. Okay, plus c, and that's c. We don't know what c is because it's an indefinite integral, dx. So you can put this, and you can, if you you can just leave your answer like this. We have already done the integration. So x squared over 2 plus 2x plus c. The most important thing is that show that you know that you have to do some algebraic manipulation. You have to do some algebraic manipulation. Okay, so the next one is definite integral. Number 6 is definite integral. So let's go to definite integral number 6. One thing about number 5 is you must show that you know that you need to do some algebra. Do whatever you have to do to simplify that function. Of course, if you actually integrate it like that, it's going to be more difficult to you. And secondly, if you do any substitution there, your answer will give you 0 over 0. Remember that 0 over 0 is indeterminate. It's not allowed. It's a mathematical fallacy. You can't do that. All right, so let's go to number 6. On this page, we're doing only 3. On this page, number 6. We're told to use geometry, actually. So we are going to use both of them. We'll use geometry to evaluate the definite integral. So actually, so let me draw a figure. This geometry. So this is, I'm going to draw. And then that number, the function says this f prime x is equal to 6. So this number is x, f of x prime x equal to 6. That number there. So, which means y is equal to 6. So, and so if I draw a line, it's a straight line. If I draw a line there, and then I'm told that the interval that I'm going to, the area under the curve should be 0 to 6, or 0 to 3. In other words, I only need to find the area under the curve. Well, everybody knows this figure. This figure is actually, forgive my diagram. The diagram is not drawn to scale, sorry. But anyway, so this is 3, it's a rectangle of length of 3 and width of 6. So this is 6. So the rectangle is not drawn right. I can now, okay, let me clean it so I can make it better. Make it better. Okay, so let's redraw that triangle. Okay, so this is my figure, and this is the line 6, and this is where 3 is. It looks much better now. So 0. And then if I show I'm told to find the area under the curve, but curve is a straight line, and I'm told to use geometry. Use geometry to do this integral. So I'm going to use geometry, and I'm going to do it by integral using all the formula, and I can do it by calculator. I'm going to show you 3 ways you can do this. Very easy. Okay, so now I see that I have a rectangle of the height of 6 and the width of 3. All I have to do is area of a rectangle. Area of a rectangle is length times width. 3 times 6, which is 18. So the area is 18. Remember, it's area. Remember, it's area. Your answer must be unit squared. Your answer must be unit squared. If you write units, your answer will be wrong. You are actually, my lab math will give you a partial credit because it's area under the curve. Area is square unit. So don't forget to make sure that you have square unit. Another way you can do this is you can check your answer. So let's actually pull up our calculator and check our answer. I hope we can check our answer using our calculator. So let me see if I can. I'm going to stop sharing so I can pull my calculator up. All right, so I'm going to pull my calculator up right now. So where are you, my calculator? And then I'm going to share again. Okay, so I can use calculator because suppose what I'm doing is long, or suppose I don't know whether I'm right or wrong, I can check my answer with calculator. So I pull my calculator up and I'll go to math and I'll arrow up and I'll find F integral. And this is F integral. And it's asking me what is the limit? What is the lower limit of this integration? Is 0. What is the upper limit of this integration? It is, what is it? It is 3. The lower limit is 0. The upper limit is 3. What is the number? In other words, what is the function? The function is f of x equal to 6. So I'm going to put 6 there. This integration is in terms of what variable? It's in terms of x. So the variable of integration is x. So I'm going to hit enter. So my answer is 18. So it doesn't really matter. If I use calculator, I'll get the same answer. If I do it algebraically, I get the same answer. Okay, so here's another thing they can ask you. They can ask you to do it algebraically and show your work with integration. Okay, so now I'm going to show my work with integration. So I'll bring down the function. The function is, bring down this function. And this function is integral from 0 to 3 of the function 6 dx. The variable of integration is x. Is x, so dx. What's wrong with my pen? All right, so that is dx. dx. Okay, so I will now go back, get my, what are you moving up and down? Okay, so it is dx. I'm not sure what this is doing. Okay, I'm going to turn this off and I'll turn it back again so I see what it's doing. Going to turn it off.